For years, the moon has been humanity's silent witness, but now something humanity built is about to slam into it at more than 5,400 miles per hour. And for scientists, this accidental collision could become one of the most important lunar experiments of the decade. It sounds like the beginning of a science fiction movie, but this is real. The object isn't an asteroid. It isn't a military weapon. It's a discarded upper stage of a SpaceX Falcon 9 rocket, a piece of hardware that completed its mission long ago but never found a final resting place. Instead, it spent more than a year drifting through the Earth-Moon system, pulled by gravity into an unavoidable collision course. The story begins on January 15, 2025. A Falcon 9 rocket launched two ambitious lunar missions. One was Firefly Aerospace's Blue Ghost, which successfully landed on the moon. The other carried Space's Resilience lunar lander from Japan. After delivering its payload, the Falcon 9's upper stage had completed its job. Normally, many rocket stages either burn up in Earth's atmosphere or are sent into disposal orbits. But this one remained trapped in the complex gravitational tug-of-war between Earth and the Moon. With very little fuel remaining, there was no practical way to steer it elsewhere. It simply became another piece of deep space debris. For months, astronomers quietly tracked it. Among them was veteran orbital analyst Bill Gray, whose software has been used for decades to calculate the trajectories of asteroids and spacecraft. In late 2025, Gray's calculations revealed something remarkable. The rocket wasn't escaping. It wasn't returning to Earth. It was heading directly toward the Moon. Subsequent observations confirmed the prediction. Now, barring an extraordinary gravitational surprise, the impact is expected on August 5, 2026, near the Moon's Einstein Crater, close to the western limb, visible from Earth. The numbers are staggering. The rocket stage weighs roughly 3,900 kilograms, stretches nearly 40 to 45 feet long, and will strike the lunar surface at approximately 8,700 kilometers per hour, or roughly 7 times the speed of sound. When it hits, scientists estimate it could excavate a crater roughly 90 feet wide and about 16 feet deep. Thousands of kilograms of lunar material may be blasted into space. Some simulations suggest the tallest portion of the ejecta plume could climb nearly 100 kilometers above the lunar surface before gravity pulls it back down. At first glance, that sounds destructive. In reality, the Moon experiences impacts all the time. Every crater visible through a backyard telescope tells the story of billions of years of cosmic bombardment. Compared with natural asteroid impacts, this collision is relatively small. Yet what makes it extraordinary isn't its size. It's that scientists know almost exactly what is hitting the Moon, where it will strike, and when it will happen. That almost never occurs. Usually, meteoroids arrive with little warning. This time, researchers can prepare telescopes, spacecraft, and computer models before the event even begins. NASA's Lunar Reconnaissance Orbiter is expected to photograph the impact site before and after the collision. South Korea's Danuri Lunar Orbiter may also observe the aftermath. Ground-based observatories across North and South America are preparing as well, hoping to capture the impact flash and the expanding cloud of lunar dust. Researchers believe the debris plume may remain visible for around 90 seconds, while finer particles could linger even longer. If observations match predictions, scientists will gain valuable data about how impacts eject lunar soil, how dust spreads across the surface, and how future lunar infrastructure might be affected by similar events. This matters because humanity is returning to the Moon, NASA's Artemis program, commercial lunar landers, international partnerships, future habitats, mining proposals, power stations, communication networks. The Moon is transforming from a distant destination into an active frontier. Understanding how debris behaves during impacts is becoming increasingly important for protecting astronauts, equipment, and future bases. Ironically, history has prepared us for this moment. During the Apollo era, NASA intentionally crashed the upper stages of Saturn V rockets into the Moon. Those controlled impacts generated moonquakes that Apollo seismometers recorded, revealing details about the Moon's interior. This new collision is different. It wasn't planned, but scientifically, it offers another rare opportunity to learn from an impact whose source is already known. There's another lesson hidden in this story. As more governments and private companies race toward the moon, deep space debris is becoming a growing challenge. Unlike satellites in low Earth orbit, objects traveling through cislunar space can wander for years before gravity redirects them. Today's harmless rocket stage could become tomorrow's navigation hazard if traffic around the moon continues to increase. Experts say the event highlights why future lunar missions will likely require stronger international standards for spacecraft disposal and long-term traffic management beyond Earth orbit. Yet despite those concerns, the overwhelming feeling among planetary scientists isn't fear. It's excitement. Opportunities like this are incredibly rare. Instead of scrambling after an unexpected event, researchers have months to coordinate observations, refine simulations, and compare predictions with reality. Every image, every measurement, every grain of lunar dust that rises into space could improve our understanding of impact physics and help shape the next generation of lunar exploration. Sometimes the greatest discoveries don't come from perfect planning. Sometimes they come from accidents that science refuses to waste. In just moments, a forgotten piece of human engineering will become part of lunar history. Not as a failure, but as an unexpected experiment that could help humanity prepare for its future